All right, group, this is our lesson 3, modeling with quadratic equations, part 1 notes. So here under example 1, we're really going to be diving into some word problems. And so you'll see the equations provided for you. We do have a graph here that's already drawn for us, which makes it really, really nice. However, you can definitely utilize Desmos if you're given an equation. Just make sure if you're utilizing Desmos, that you change your variables into y and x. So for example, if we were using Desmos for this, we would have to rewrite that to have y and x in it. Just a heads up for the future. Okay. Don't forget to include our units. Super important. Okay. So here it says the graph shows the height h. Okay, so here's our height. You can see it labeled here. In feet of a rocket after t seconds. Okay, so time's down here in seconds. After it's launched. The path of the rocket is given by this equation, and we can see it in the graph. So it says, how long is the rocket in the air? So the rocket is shot off right here. Okay, it's in the air, it's in the air, it's in the air, it's in the air, and then it lands. And it lands at 8 seconds. So that means the rocket is in the air for 8 seconds. Okay, part B, what is the greatest height that the rocket reaches? Remember, our y-axis is height. So right up here, okay, if we look at this, this is definitely our highest point, and it looks like it's here between 250 and 260. So we're going to say about halfway in between at 255 feet. Okay, then it says, how high is the rocket after 1 second? So after 1 second, it's kind of rough. It's looking like 110, a little over 110. Let's say 112. 112 looks pretty good. Okay, remember, these aren't exact because we're just looking at this drawn graph. To get exact, we'd have to use Desmos and put our equation in. Okay, after 2 seconds, how high is the rocket? So at 2 seconds, we're going to go up. It looks like it's a little over 190. We'll say 191. Okay, after 2 seconds, is the rocket going up or down? So if you look at the rate of change here, it's definitely still going up. The shape of the rocket is going up, so it's increasing there. Okay, after 6 seconds, if we go up and look, it says how high is the rocket? It looks about the same as 2, so we'll say 191. Again, these aren't exact values because we'd have to look at Desmos to get those exact values. After 6 seconds, is the rocket going up or down? So at 6 seconds, that rocket is actually headed down. Okay. Do you think the rocket is traveling faster from 0 to 1? Okay, so 0 to 1, let me grab my highlighter. So 0 to 1 is right here. Okay, or from 3 to 4. So 3 to 4 is right here. Okay, so the easiest way to look at that is to see which one looks like it's a steeper part of a line, right? Like if I was to connect these 2 dots, okay, and if I was to connect these 2 dots, which one's steeper? Definitely from 0 to 1. We would say the line is steeper connecting those points. Okay, now letter I says, using the equation, find the exact value of the height of the rocket at 2 seconds. Okay, so I'm going to go to Desmos. If you don't have a regular calculator, you can use Desmos, so that's why I'm going to use that because I know that everybody can use Desmos to do this. Okay, so for our equation, right, it's negative 16. Our time that we're plugging in is 2 squared plus 128 times 2. And again, that equation was right up here, right? So I just plugged in my time of 2. And I'm going to put this into Desmos and get out an answer. Okay, looks like it comes out as gosh darn it, sorry about that. Looks like it comes out at 192. We were really close at 191 when we were guessing up here based on the graph.